Okay, question two. Question two. Figure one shows the circuit symbols for three different components. What component is a variable resistor? All right, well, all of these components are resistors because this symbol here means resistor. But which one is the variable one? Well, the variable one is the one with the arrow in here. That's the variable resistor, so it is component A. Which component is the thermistor? So that's the resistor that's based on temperature. And that is here, that's component C. In which component will the resistance decrease when the temperature increases? Well, should be thermal. So it's the same one. So it's component C, because that's a thermal resistor. So as you increase the temperature, the resistance goes down. In which component will the resistance decrease when the light intensity increases? Well, these lines there are meant to be light. This is a light dependent resistor, an LDR. So the resistance on this one depends on the light. So of our three resistors, we've got the first one, A, that is a variable resistor because we can manually change the resistance. B is a light dependent resistor, so the resistance depends on the amount of light. And C is a thermistor, so the resistance depends on the amount of heat or the temperature. So in which one will the resistance decrease when the light intensity increases? That is B. Figure 2 shows four different arrangements of resistors. So we've got these two here are series. What that means is one after each other. So in series, you add them together. And these two here are parallel. So in parallel, the rule is the resistance is less than the lowest resistor. Okay, so we could work these out. So 10 plus 10 is 20 ohms for that one. 5 plus 5 is 10 ohms. This one, the lowest resistor is 10, so this would be less than. That symbol there means less than. I can just write it, so less than 10 ohms, and this one here is less than 5 ohms, because that's the lowest resistor. So the two arrangements are in series, two of the arrangements in series and two in parallel. Describe the difference between series and parallel. So we could say something like in a series circuit, there is only one pathway for the current to follow. So, for instance, this one, the current has to go through that one, it has to go for that one, it has to go there. So that's why we add them together. In the parallel, the current can go there, but then it can even go up there and through that one. So it only has to get, that in that journey is the only resistance of 10 ohms. Or it could have decided, actually, I'm going to go this way and go for that one. So again, there would only be a resistance of 10 ohms. The fact that you can choose means you have to say, well, it's less than 10 ohms because it could have gone either of the ways. So, describe the difference. So in a series circuit, there is only one pathway for the current to flow. And then we just say in a parallel circuit, there are multiple pathways for the current. So in this one, there's two pathways, but in a parallel, it can be any different amount of pathways, or we could call them branches. Which arrangement has a resistance of 10 ohms? Is arrangement R, is exactly 10 ohms. I know we said that arrangement Q here is less than 10 ohms. So some people might be tempted to put that, but it's the one that is exactly 10 ohms is the one where we're adding our two 5 ohm resistors together. So it's arrangement R. Which arrangement has the highest resistance? So if we go to there, the highest one is P, because that's our 20 ohms in here. So that's P. A student connects a resistor to a cell for 60 seconds. The current through the resistor is 0.97 amps. Calculate the charge flow. So I like to get a highlighter when we're doing any of these type of questions and just highlight some values. So anything I see where I'm going to highlight a number with a unit, or I'm going to also highlight what it's asking me to find, which is the charge. And the thing that it's going to ask me to find, I normally put a box around that as well, and that's just because I want to know, that's what I'm actually looking for. That's what I want to make the subject of my formula. So 60 seconds, that's a time. That's the value of time. Seconds are the right units of time, so I can leave that alone. And it tells me there that that is the current. And obviously I want charge. So, luckily, I'm given the formula here that I need. So that's nice. But I could be asked, or you could be asked, to go to the data sheet. So this thing here, I'll just rub that one out because that's one I've done earlier. You could be asked to go in there and you could be asked to find that equation yourself. So we would look for one that has current, time, and charge. Go on here, charge flow, current, and time. Q equals I times T, which is what we've been given. Charge flow is current times time. Give your answer to two significant figures. So what we do is we use FIFA. FIFA is just, the acronym FIFA, like the video game, so it helps you remember it. F is the formula. We've been given the formula. I is where we put our values into our formula. So instead of charge flow, we would put a number, but we're not given a number because we're asked to calculate that, so we're going to leave that as charge. So charge is equal to, now instead of current, we're going to add in 0.97. You need to be aware that amps are to do with current, in case that you're not told that. And we're going to multiply that by the time, which we're told is 60 seconds. A common thing they could do to make this question harder would be to say the 1 minute, and you would have to know, well, 1 minute is 60 seconds. So the F from FIFA is if we had to rearrange it, or we had to do something like they'd given us a different unit, or we had to make the time the subject. It's unlikely to have to rearrange on the foundation exam, but it might happen towards the end. So we don't need to do anything there. And the A is just where we're going to write our answer. So we're just going to do this sum, and we're going to get an answer. So let's have a look. 0.97. We're going to multiply that by 60. Is going to give us 58.2. So 58.2. I always just like to write my answer down there because I just like to check it again. 0.97 times by 60, 58.2. So I've checked it twice. Pretty confident at that point. 58.2. And we're given the unit here, so we don't need to write that down. Okay, that is the end of question 2.